This video is part of an online course of Calculus 1, and I'm going to talk about transcendental functions, which is basically an essential class of functions. Okay, what are they? A function that cannot be described by basic algebraic operations. If it can be described by basic algebraic operations like adding polynomials or subtracting polynomials, then it's called algebraic function. If not, it is called transcendental functions. Okay, they are transcend or basically go beyond algebra. Okay, three classes of them are very important: trigonometric functions, exponential functions, and logarithmic functions. Okay, let me just briefly go over them. So I'm gonna start with trigonometric functions. Trigonometric functions are basically relates the ratio of two sides of a right triangle. Okay, one of them is sine of x. I'm gonna show it to you by graph. So this graph is periodic. This is sine of x. This is x-axis, this is y-axis, and the point that I have in here is pi. The point that I have in here is pi over 2. As you see, the domain of this function is r, and the range of this function is the interval between -1 and 1. It cannot go beyond -1 and 1. Okay, so this is 1, this is -1. Okay, and the other one that is, you probably know, it would be cosine of x. I'm gonna graph cosine of x for you. Let me use another color for that, like this. So this is y equals to cosine of x. So at pi, cosine of x is equal to -1, and at pi over 2 it's equal to 0. And the same thing, the domain and range of this function is r, and the interval between -1 and 1. Okay, I'm gonna talk about trigonometric functions in details later in another video, but this is basically sine, cosine, tan, and cotan. And tan of x is a function that is sine of x over cosine of x, and then cotan of x is cosine of x over sine of x. And we're gonna discuss all about trigonometric functions later on. So another class of transcendental function would be exponential functions. Exponential functions. And what are they? Exponential functions are like this. A function f of x is equal to a to the power of x, where a is a positive constant, and a is not equal to number 1. Okay, then domain and range of this function is what? The domain, as you see, you can put any number into here. So it's all real numbers, the interval from negative infinity to positive infinity, everything you can put in there. And the range of these functions, exponential function, which is basically a number to the power of x, the range of that is 0 and positive infinity. Let me graph some of them for you. For example, this is x-axis, this is y-axis. I'm gonna graph y equals to e to the power of x. What is e? E is a number 2.71 something else, and e is just basically a number, but the number is very important. And e to the power of x. What is the graph? The graph of e to the power of x is this. When x is equal to 0, I get e to the power of 0. Any number to the power of 0 is equal to 1. So the y-intercept is 1. Okay. We use this for example, population growth in mathematical modeling, right? Let me graph another exponential function for you. For example, the function y equals to 1/2 x. So the graph of this function looks like this. Okay, this is y equals to 1/2 to the power of x. Okay, and again, when x is equal to 0, I get 1/2 to the power of 0. Any number to the power of 0 is 1. That's why the y-intercept here is 1. Okay, we use this for example, use for radioactive decay. Radioactive decay. And you see the difference between these two? This one is increasing, so whenever that the base a is positive, we have an increasing function. But then here, a is less than 1, or base is a number that is less than 1. It should always be positive, greater than 0, and not equal to 1. But when it is between 0 and 1, some fraction, some decimal in here, then we get a decreasing function like this. That's the difference between these two. Okay, that's all I wanted to cover for the exponential function. So right now, let's go to logarithmic functions. Logarithmic functions. This is another class of transcendental functions. Logarithmic functions are like this. So f of x is equal to the log of x to the power of some number a. Okay, a is a positive constant again. It's called the base of the logarithmic function, positive constant. And a is not equal to 1. And x here should be something positive. All real numbers, okay, that are positive can be put in as the x. So if I ask you what is the domain, you can say that the domain is all real numbers from 0 to positive infinity, okay, not including 0. And the range of this function is negative infinity to positive infinity. Everything could be as a range. If I want to graph it, x-axis, y-axis, and the graph of our logarithmic function looks like this. Y equals to log x to the power of 2, for example, here. And then when y equals to 0, okay, I get 2 to the power of 0, which is 1. So at x equals to 1, I have the intersection of our logarithmic function to the x-axis. Okay, I'm going to cover logarithmic functions later on in the next videos. And I just wanted to cover these 3 transcendental functions. As you see, Trigonometric functions, exponential functions, and logarithmic functions cannot be described using algebraic operation, plus or minus or subtraction of polynomials.